In the last video, we looked at double slit diffraction, and we looked specifically at a set of equations. D sine theta, which is if you have two waves of light reaching the same point from different sources, in the double slit diffraction experiment, this turns out to be the path length difference between the two. And then we know that if that path length difference is an integer multiple of the wavelength, then we get constructive interference. If that path length difference turns out to be a half integer multiple of the wavelength, we get destructive interference. In both of these, m is called the order. M is equal to 0, plus or minus 1, plus or minus 2, etc., etc. So this is double slit diffraction, where remember d was the distance between the slits, theta was the angle made from the central point of the barrier to the point in question, where there's a bright spot or a dark spot. But these are the equations for double slit diffraction. Okay, so you don't have to use double slit diffraction. In fact, a very common way of diffracting light is to create what's called multi-slit diffraction. If you take a little piece of paper, if you take a little piece of plastic and you scratch on it really fine lines. Now you can't do this with your nails or anything. Usually these are 3D printed or done with machines. Really fine lines that are really close together. These lines, these scratches start to act like slits. They start to act like holes in a barrier, where the slits are actually, or the scratches are actually the barrier, and the region between the scratches allows light to pass through, just like we saw in the double slit diffraction. If you do this, you get the same effect that you do with double slit diffraction. It just comes from multi-slit diffraction now. So let's develop the set of equations to characterize multi-slit diffraction as opposed to double slit diffraction. All right, here they are, right? It's the exact same equations, which is really good news, because we know how to handle these equations. You still have integer multiples of the wavelength for constructive interference, half integer multiples for destructive interference. D, though, we've got to be careful here. D is now, for multi-slit diffraction, no longer the distance between the only two slits. This is the spacing between all of the slits. So it's pretty similar. Where this works out to be a little bit tricky are usually in problems that you're given, where you will be given something says a diffraction grating has 8,000 lines per centimeter, or something along those lines. That's usually how these are characterized in problems and in real life. And so you go, well, if they're 8,000 lines per centimeter, what is the spacing between them? So I think the units here are going to tell you how to do that problem. If you're looking for D, what is the distance between the space, or what is the spacing between the lines here, which works out to be the spacing that you need D. If you have 8,000 lines per centimeter, what we need to know is how many centimeters are in between each line, right? That's what we're looking for. So the units, I think, invite you to solve the problem just by inverting it. This would mean the distance would be the inversion of this. See, if I invert the unit, I get centimeters per line. I mean, per line is not a real unit. So if I invert the units here, I just get centimeters. But what this tells you is the distance between the lines, which is your distance D. So just invert it. 1 over 8,000. Careful with your units, centimeters. Now you're going to have to probably convert this to something else besides centimeters. Usually wavelengths are going to be given in nanometers, so it's helpful to have your distance in nanometers. Of course, you're free to convert all of them to meters if you want to. But this is a really simple way to solve that problem, which at first might seem a little confusing. If you're given your distance between the slits in this, if you're given the characterization of the diffraction grating, which is what this is called, like this, you just invert this number to find the distance between the slits.